Hi, I'm Regina Brazel with Be the Math, and this video is on basic notes of exponential functions. First off, there are a few rules for exponential functions and a base formula. Our base formula is y equals ab to the x power, and each one of those has a certain meaning. And so what you look at is, of course, your y value is just that. It's going to be what your equation equals, your answer, and your y coordinate on your graph. Your a value is your initial value. It's what you started with. And your b is your base. And your x is your exponent. And so for an equation to be an exponential function, it has to follow these certain rules. Your initial value cannot be 0, okay? It cannot start out with 0, because if you start out with nothing, you have nothing. And then your base, your b value, which will eventually be your growth or your decay value, has to be greater than 0, but not equal to 1. And so think about that. If it's equal to 1, what is 1 raised to any exponent? Power. Well, 1 times 1, however many times you do it, will always be 1. So your rate or your base can never be 1. And then your x value can be any real number. It can be a decimal, it can be a fraction, it can be positive or negative. It doesn't matter what your x value is. It can just be any real number. Okay? So those are the basics. Just y is your y value, a is your initial, b is your base, and x is your exponent. So how do we use these once we have our exponential functions? There are graphs. Then they look a certain way, they have a certain pattern. They may not always touch the y-axis like this. They may move up or down, but your growth will always start low and increase really quickly. Your decay will start really high and decrease really quickly. And for those situations to work on a growth equation, your b value is going to be greater than 1. So 1.1 or 2 or 10, it doesn't matter what that rate is or what that b value is, it's going to be larger than 1. For a decay value, your b value is going to be between 0 and 1. And what this says is b has got to be sign's wrong. Let me fix that real quick. B has got to be greater than 0 and less than 1. And so your values are going to be between 0 and 1. Okay. Now, I know this slide's a little busy. Let me put up my curtain. Well, let me talk to you about what these mean. Okay. So when you have a growth or decay, certain things in your functions must happen. On a growth, your b value is going to be 1 plus your rate. And so our equation would be y equals a times 1 plus r to the x power. And so it's always this 1 plus r that creates our b for a growth. For a decay value, you're going to have 1 minus r, and so your equation would be, if you replace the b with the 1 minus r, it's going to be y equals a times 1 minus r to the x power. Now, r wasn't in our original equation, so what does r mean? Well, r is your rate, which is usually some sort of percent, and you have to convert it to a decimal to use it in the equation, and x is the amount of time passed. Now, you need to be careful with that, because if they tell you a year and they want you to calculate it in months, you have to convert your years to months and so forth. So that's just something that you have to look at with the problems. And so a growth formula is your initial value times your rate plus 1 to the x power. Your decay is your initial value times your 1 minus your rate to the x power. And so let's look at a couple of graphs, because this is just a basic video to tell you about exponential functions. So when you're graphing, there are certain steps to take for any function for that matter. But the first thing you want to think about is, in the problem, are you graphing a growth or decay problem? Because that determines what function you're going to use. If it tells you it's increasing, that's going to be a growth. If it's telling you it's decreasing, that's going to be a decay. And so then, after you determine your function, you create a table of values using your possible x values. Now, the reason I say use your possible x values is if you're looking at a 2-month growth for something, or a month growth of something, you don't want to use 500 as a possible x value unless you're looking that far into the future, but hopefully you're not trying to graph something to the 500th power. And then plot the points on the graph, and then you just connect your points from left to right. Okay, so let's graph one. All right, so here's my equation. Y equals 2 to the x power. Notice there's no a in this particular problem. This is the same as saying 1 times 2 to the x power. But because anything times 1 doesn't change, you can just leave the 1 off and write it like this. And so let's think of some possible x values we can use. We can use negatives if we want to, or we can just start with 0. Let me change colors. And go to maybe 4. And that depends again on the problem you're doing. This will work just fine for graphing this one. So if I'm plugging this in, this means my x value here becomes 0. So I'm going to have 2 to the 0 power. If you remember from rules of exponents, anything to the 0 power is just 1. So my 0 is going to be 1. And then 2 to the first power is 2 times 2, just 2. So it's 2. 2 to the second power is 2 times 2, which is 4. 2 to the third power is 8. 2 times 2 is 4, times 2 is 8. And then 2 to the fourth power is going to equal 16. And so now you just plot those points. So 0 is 1. 1 is 2. 2 is 4. 3 is 8. And 4 is 16. Notice the gap between our points has gotten larger each time. And that's a sign of an exponential function. And so we have a growth because it's increasing rapidly, and it is our basic exponential function. All right, let's look at one more. Okay, here's another example, and this one doesn't give us our equation. So we're going to have to use our rules of exponential functions to figure out what our equation is. So it's given us a little information. A equals 5. Our growth rate is 10% per year, and we are graphing for x years. So basically, we're in control of what x values we put into our equation. So if you remember, your growth equation is y equals a times 1 plus r to the x power. And so we now have to figure out about what that is. And so when we start writing our function, it tells us our a, which is our first letter, is 5. And then we have to put 1 plus our rate. Well, remember with a percent, you can't use a percent in a problem. It has to be in a decimal form. And so 10% equals 0.1. And so 10% equals 0.1. And so we're going to put 1 plus our 10% to the x power. Now this gives us our equation to graph. And to save us a little time, I went ahead and worked these numbers out because they're not exact. And so let's put in 0. And anything, it doesn't matter what it is, to the 0 power is always 1. And 1 times 5 is 5. If you put in a 1, 1 plus 0.1 is 1.1 times, it's just 1.1 to the 1 power. So it's going to be 1.1 times 5, which is 5.5. And then if you put in a 4, you're going to get 1.1 to the 4th power, which is approximately 1.46, I think. And then if you work it out, you get 7.3205. And that didn't write very well, but 0.5. Okay. And so now we just have to graph those points. And so we plot 0.5. And then 1 is 5.5, so that's in between. And then we jump to 4, and we go up to 7, and then about a third. And so our graph's going here. And so to get really our graph going here, we would have to go ahead and plot a couple of other points to see, but it's going to be increasing in this direction. I know in this video I didn't show you a decaying graph, but the principles are the same. You plug them in and you just connect the points through each of the dots from left to right. So I really hope this helps a little bit on understanding exponential functions, and thanks for watching. Please subscribe and like my videos. Subscribe to my channel. It does help a lot. Thanks again.